Hi, I'm Lee Kerwin. I'm a project engineer here at EWI, and I'm going to be going over large format metal additive manufacturing with you. Behind me is our RPM 557. The name comes from the size of the system, so it can build parts in a build envelope of 5 feet by 5 feet by 7 feet tall. So in this you can do really, really large components out of exotic aerospace metals in an inert environment. You can achieve very fine details with a spot resolution of 20 thousandths of an inch and working at a layer height of down to 10 thousandths of an inch. So with that we can build huge parts over long periods of time. The system will run automatically with a 3-axis gantry and a tilt and rotary table to trace out your geometries and build up layer by layer. The RPM's build chamber is an inert atmosphere that's sealed, so it's filled with argon, and that helps reduce the oxygen levels to below 10 parts per million. And with that build environment, we can deposit materials like titaniums, aluminums, other exotic aerospace alloys that would oxidize heavily in a normal atmosphere. Using this process, we can deposit freeform, freestanding geometries with overhangs that are unsupported. These are geometries that you wouldn't be able to achieve with traditional manufacturing, such as machining or forging, and these parts are too large that you wouldn't be able to print them in any other metal additive process. So this technology is really useful because aerospace companies, the Air Force, and other industries are seeing equipment that is failing and breaking and wearing out. With this technology, you could put in a pre-existing part that's only partially broken and deposit just on the area that you need to, and build that part back up, certify it, and put it out and into the industry again.